Now we're going to look at simplifying radical expressions. So sometimes radicals aren't perfect squares, and we can put it in our calculator and get an approximation, but that's not an exact answer. There is a way to simplify radical expressions. So we are going to look at our key terminology first, and then we'll look at some examples. The product of two nth roots in the nth is the nth root of the product of the two radicands. The product rule for radicals applies only when the radicals have the same index. When no index is written, roots are understood to be square roots. And to simplify an nth root, identify factors in the radicand with exponents that are multiples of n. So let's look at some examples. Now in these examples, they're set up as multiplication problems, and we can multiply them if their index or their indices are the same. And then we can look at simplifying the product. So for the first one, when I multiply the square root of 10 times the square root of 11, I get the square root of 110. Now the only way I can simplify it is if it has a perfect square factor, meaning of course 1 goes in, but then our next perfect square factor is 4, so we would check to see if 4 goes in, and 9, and 16, 25, 36. These are all my perfect squares. And if any of these are factors of 110, then I can simplify. I don't think any of these go into 110, not yet anyway. 49, that'd be 7 squared, 8 squared, 64. 9 would be 81, 100, 121. Since none of those are factors of 110, that means this cannot be simplified, and therefore we would just leave it square root 110. That is an exact answer. If I were to put this in my calculator and get an approximation, then that is just an approximation, not exact. So we like to have exact answers. Since we just did one with numbers, let's look at 15. It also has just numbers and no variables in it. Now when I look at the square root of 14 and I look at my possible factors that can simplify it, none of those divide evenly into 14, and none of my perfect squares divide evenly into 21. However, if I multiply them together and I get 294, do any of these divide evenly into 294? So I would just get my calculator and I would try to start dividing numbers out. We want to find the largest one. So I do have more perfect squares that go past 121. So I would probably just start with 121 and see if it goes in, and it does not. Then I would take, and I would just keep dividing. 100 I know will not go in evenly. 81 potentially, and it does not. Let's try 64. It does not. How about 49? I'm thinking this one might, just because 49 comes from 7, and both 14 and 21 have a 7. So I'm thinking 49 might work, and it does. So this is the same thing as 49 times 6. Now, since I can rewrite 294 as 49 times 6, I can actually take the square root of 49, which is 7. So this simplifies to 7 square root 6. And that would be my simplified answer. So what we do is, when we multiply them, we look to see, does our product have a perfect square factor? Because if it does, I can, and I can take the square root of that perfect square factor. Okay, let's look at some division problems. I have the square root of 30x over the square root of 5x. Well, I can rewrite it all as 1, since they both have a square root. And then it's easier to see that I actually can simplify my fraction. The square root of 30 over 5, that is 6, and x over x, well, that cancels each other out. So it looks like my final answer is going to be just the square root of 6, and I can't take the square root of that, so I'm just going to leave it square root of 6. Now on this one, they're both cubed roots, which is fine, which means I can rewrite them as 1 instead of 2 separate, which is going to leave me the cubed root. 30 divided by 3 is 10. And 10 is not a perfect cube, so we're just going to leave it cubed root of 10. Now let's look at the third one down here, 23. I have 6a to the 5th b over 2a. Now again, they're both square roots, so I can write them as 1. And I know that 6 over 2 simplifies to 3. A to the 5th over a simplifies to a to the 4th. And b doesn't simplify with anything, so it's just going to stay b. So all of that is underneath our radical sign. Now I know that I can't take the square root of 3 and I can't take the square root of b, but anytime I have an even exponent, I can take the square root of that. So I can actually take, since the square root of a to the 4th is a to the 2nd, I can pull out the a to the 2nd, and that leaves me just a 3 and a b. So what I was able to do is rewrite these with their own square root symbols. And this is just another way to look at this problem, and this one I was able to actually take the square root of that, so that's what I put there, and then the 3 and the b just stay underneath the radical sign because I cannot take the square root of those.